Hi, hello, hola, yo, this is Jay, and I hope you are at peace. So, today we'll learn how to make aircraft wings in three different ways. So, without wasting our time, let's get started. So, our first wing is going to be a thick wing. So, we'll go to mechanical design, part design, and we'll rename it as thick wing. So if you need a rough airfoil section and a thicker wing, you can go for this way. We'll start by creating a sketch. First draw the chord line. Now we'll make the curvature at the leading edge. We'll just make a simple arc. We'll again make an arc and connect the leading edge with the upper profile of the wing. And we'll connect the trailing edge to this upper surface. We'll trim the unnecessary parts. And here we are done with the profile. So we'll just pad this profile, and we'll not pad it completely. We'll give the thickness as 1 mm. Give it 2 mm. So since we are making a thick wing, well, we can add supports or spars, as you can say, to strengthen it further. So let's do it. Let's create support. We'll first draw a sketch and then we'll pad it. So here we are with our sketch, and now we will pad it. We'll create a new body and go to pad, say yes. Since it's an open profile, we'll just give thickness to it, length 100, mirrored extent, thickness as 1 mm. Click on OK. So as you can see, you have given a support at the trailing edge of the wing. Let's create one more support at the region where the thickness is maximum in the wing. We'll create another sketch. So in this way, you can add as many supports as you want and wherever you want. So that's it. Here we complete our thick wing. So our next wing is going to be a thin wing. Well, a good example of thin wings would be the RC airplanes and the rotor blades of the helicopters. So the airfoil section of these thin wings have to be very accurate up to the last mm, So for that, you might consider the option of importing the points rather than drawing them by yourself. So we'll just do that. For that, we'll go to a website called as airfoiltools.com and search for the airfoil. Well, for this wing we are going to go for 0012, and here is the NACA 0012 airfoil. Well, I must tell you that the NACA 0012 is not only one of the most popular airfoils used on the helicopter blades, but it is also one of the most tested airfoil sections in the whole world. So, and as you can see, the modified version of the same airfoil section is being used in the Bell AH-1 helicopter over here. For now, we'll go the simpler version of this. We'll send it to airfoil plotter and we'll keep the chord length as 200 and we'll download it. So here are the coordinates. We'll copy them. We'll copy them into our Generative Shape Design file. And we will import them. And here are our coordinates. Well, if you don't know how to import coordinates, well, it's not a very big deal. You can check out my another video in which I have shown how to import coordinates into CATIA from Excel. So just check it out and you will be fine. So let's proceed here further. Well, after importing the airfoil, you must check whether the profile is closed or not. We'll check that, and I think yes, the profile is not closed, so we'll close it. We'll go to Generative Shape Design and we'll go to Insert, Advanced Operations, and Extrapolate. So we'll extrapolate them. We'll use the endpoint as this, the curve, and length be 10 mm. Well, make sure to uncheck the assembly result option and click on OK. After that, we need to extrapolate even this, so we'll again use the extrapolate option. We'll check this point, we'll choose this point and click on assembly result. This time we'll choose up to element and we'll choose the element as this. Click on OK. We'll now go to split. Where is the split option? So we'll choose the element to cut will be this one and the cutting element will be this one. Click on preview and OK. Now we have closed the profile. Well, now we need to join them, so we'll use the join option and we'll select our profile and both of these extrapolated lines. We'll click on preview and as you can see, the whole profile has been joined. Click on OK. Now we are ready to extrude it. So let's head back to our part design and let's define in work object. Click on pad. We'll select the profile and I'm going to extrude it. It's very short, right? Let's double it. here is our thin wing. So now let's fillet the edges. We will go to the edge fillet command and select both the edges and give the radius as 5 mm. And here we have our thin wing with smoother edges. So that's it, simple, right? So now we'll check out our last type of wing, and it is swept wing. We'll create a new part and rename it as swept wing. Well, these are the types of wings which you nowadays see on every other airplane. This is because they are very efficient than the earlier ones. So for this we are going to need to import 3 different profiles on 3 different planes. So let's get on with our first profile. We'll again head on to airfoiltools.com and we'll search. Well, I have decided to go with the airfoil 2411. We'll search and we'll go for this one. We'll send it to airfoil plotter, and for this we'll take chord length as 200, thickness as 150%, and let's say plot. We'll download it and we'll open it. So let's import the coordinates. Well, here we are going to plot on the YZ plane, so there is no need for X coordinates. So we are going to just put all the X coordinates as 0. And here we have our first profile. Let's check it whether it is a closed profile as mentioned earlier. And yes, it is actually. Well, I have checked it earlier. Well, now we need our second profile, and it's going to be offset at a distance, let's say 700 mm from the YZ plane, at this plane, so somewhere here. And we should keep in mind that the next profile is going to be also shifted backwards on the X axis, so somewhere around here. So the profile will start from here and go till here. So let's go to airfoil tools and give it a smaller chord length with the same thickness, and let's plot. Let's download it. So if we plot it as it is, well, it is going to be plotted on this plane itself and somewhere around here. So we are going to shift the profile by 700 mm in X direction, somewhere around here, and we'll shift it backwards at an offset of 400 mm, so it will be around here. So let's shift it in the Excel itself. We'll go into the Excel sheet. So let's shift the X coordinate by 700 mm. The Y coordinate will be shifted by 400 mm. And the Z coordinate will remain as it is. Now let's import these coordinates. And as you can see, here is our second profile. It is shifted 400 mm in Y axis and by 700 mm in X axis. Let's get our third profile now. So importing the third profile is a little bit tricky job, but I'll show you how to do it. Well, keep in mind that the winglet is going to be a little bit more backwards than the second profile. So if you look on the YZ plane, it will be a little bit backward somewhere around here, and we are going to shift it on the Z axis also. So combining both of them, it will be somewhere around here. Also, if you look on the XZ plane, you will see that the winglet will be even more farther than the second profile, so somewhere around here. And when we will combine everything, all the 3 axis offsets, you will find that the winglet tip is somewhere around going to be here. Okay, so let's just first download the profile. We'll go to the website and choose a smaller profile and a thinner one too. We'll download it and make the changes. So I worked out a little bit and found out 3 simple formulas to do it. So our x coordinates is going to be the x shift minus the y coordinates. Our y coordinates will be the y shift plus the x coordinates, and our z shift is going to be simply the offset, which in our case is 60 mm. So our x shift this time is going to be 785 mm minus the y column, the y coordinates. So okay, so I forgot the equal sign. 785 minus the y coordinate. Here it will be 480 mm plus the x coordinate, and the z coordinate will be 60 mm. Now let's get all the coordinates, and here are the required coordinates. So we'll copy them, and now we will import them. Okay, I just realized that there is a small mistake. It's 60 mm here, so it's going to remain 60 all the way along, and we need to delete the coordinates. We'll just undo it and we'll import it again. We'll check it out if it's correct. We'll choose the XY plane, and well, from this angle it looks correct to me. And yes, as you can see, we have the profile over here. Now, before we could apply the multi-section command, we need a guide curve to connect all of the 3 profiles. So we'll go to the line command, and by simple point to point choosing from the drop down, we'll select the first point of the first profile, the second point of the second profile as well, and we'll extend it a little bit. So we'll extend it let's say 100 mm. Okay, so the first and the second profile is now connected. Now we need to connect the second and the third profile, these two. So for that we'll create another plane, and we'll create the plane on the third profile, and we'll choose parallel through point, select this point, and we will be needing the plane on YZ. Okay, wrong option. Parallel through point, and the reference would be YZ plane. Here we got our plane, and let's sketch on that plane. So now we will exit the workbench and we'll connect them both. We'll go to Generative Shape Design and apply a corner over here. So where is the corner? Yeah, here it is. And we'll select the first element, we'll select the second element, and we'll select 3D corner, and we'll give the radius as 40 mm. Let's see. Okay, I think that will work. Okay, trim element 1 and trim element 2. This is our guide. Now we can use our guide option. So we will head back again to our part design and select the multi-section solid tool. We'll select the first profile, we'll select the second profile, we will select the third profile, and under guides we will choose the guide we created. Let's click on preview, and yes, here is our wing. So this is our swept wing with the winglet. Well, the multi-section solid is a wonderful command because it can create complex shapes very easily and very fast. So I have other videos on multi-section solid too, in detail as well as other parts, so you must check it out. I'm sure you will definitely like those videos, and if you like this video, then please leave us a like below. If you found that the video was helpful, then please subscribe us so that I could even help you in the future. So that's all for today, guys. See you in the next video. Adios, sayonara, goodbye, bye bye.